we have 2 days of review. Not because this is super long. I mean, if you look at it, it's only 20 questions. But the topics range from our fraction powers to solving to graphing, compositions. There's all kinds of things in here. So it's nice that we take a 2-day split here and then take the test on Friday. So practice test for 6.4 to 6.8, and it says we're going to simplify each expression and assume that all variables are positive. So after we came back from the last test, we said no more worries about absolute value. Don't worry about that at all. So I'm looking at number 1, and I always want to think order of operations. And I think, I wonder, 343 divided by 64, is that reducible? And I don't want to do it in my noggin, because I don't have to. I can put it in my calculator and see if it'll reduce. So 343 divided by 64, enter. Math number 1, enter. Oh, it's not reducible. Okay. Oh, but the x's and the y's, I can do something about that. And I want to simplify so I don't have to do more math. So, can't get rid of the 343 and the 64. But I notice the base of x on the top and the bottom, we have a 6 and a 3 for a power. And that's division, and division means subtraction. 6 minus 3, that'll give me x to the third on the top. Same thing for the y's. I notice, hey, I've got a 12 and a 6. Well, that's going to give me 6. So that's good news. No more of our variables in the denominator. That's cool. And now I have to remember what 1/3 power is. Talk to your chicken wing elbow partner. What does 1/3 power stand for? The root is where? On the bottom. So this is really the cubed root of 343, the cubed root of x to the third, and the cubed root of y to the sixth, all over the cubed root of 64. Well, then I'd grab my power chart. Since those didn't reduce, I would expect to find those numbers on my power chart, which I think I have one too. So power chart underneath third power. And I see 343, and I follow it over. Oh, that's 7. Even better news, cubed root of x to the third is what? Yeah, x, the index matches. And then, just to stick with what we were doing in the first part of the chapter, we could make it the cubed root of y to the third and the cubed root of y to the third. So we can see those two inverses. And then cubed root of 64, go to your power chart. What's cubed root of 64? 4. And last but not least, I see cubed root of y cubed. That's going to be y and y. Oh, I'm going to put an arrow up here, I think. So people that are gone will see we did this. And got 7xy squared over 4 for our answer. Now, if you're saying, Cedar Home, I just remembered the shortcut. 3 divided by 3 is 1, so that's going to be x to the first. 3 goes into 6 twice, so that's going to be xy squared over 4, and I just jumped right to that. Cool! If you want to use that, do that. Use the shortcut. Alrighty, number 2 has an issue. I don't think this would be a really tough problem for anybody, except look at that exponent. What's special about that exponent? Negative. What do we do about negative exponents again? Yeah, so let's make this the reciprocal right away. Let's not lose track of that. So I'm going to make it negative 1 over 128, because it doesn't matter if the negative is on the top or the bottom. If you want to do 1 over negative 128, you're safe. You can do that. But now, that's to the 3/7. Which of those is the root? Okay, so this will be the 7th root of negative 1 cubed over the 7th root of 128 cubed. What's the 7th root of negative 1? 7 slots, all filled with exactly the same thing and have to multiply to negative 1. What would it have to be? Gotta be negative 1. 7 through to 128. Grab your power chart. Gotta be a pretty small number, right? 2. What's negative 1 times negative 1 times negative 1? 2 times 2 times 2. There it is. Cool. Cool way to write. Negative 1/8. So there it is. Again, people always say, I'll deal with that negative exponent later, and then they forget to. Do that right away. So do the reciprocal right away, and then take care of the rest of that fraction power. Alrighty. 3. That looks pretty basic, doesn't it? We've got 2 bases of A, and we're supposed to multiply them. What do you do with the exponents when you're supposed to multiply similar bases? You do add. Oh, problem. Why is that trouble? Doesn't have a common denominator. Now, some of you will say, not a problem for me, Cedar Home. I'm just going to put those in my calculator and do 1/6 plus 2/8. Enter math number 1. Yes, you can do that. But you could also say, least common denominator for 6 and 8 is 24. So this one would need a 4 on the top and the bottom, and that would give us 4/24. The second one is going to need a 3 on the top and the bottom, and that would give us 6/24. And then, like you said, we need to add them. So that'll be a to the 10/24. And if I left it like that, I would probably miss a half a point. Can you explain to your chicken wing elbow partner why that would lose points? Yeah, it's not simplified. And again, you wouldn't even have to do that in your head if you wanted to punch in 10 divided by 24, math number 1. But most people will just look at this and say, oh, 2 goes into both of those. a to the 5/12. And the last thing I checked was, did it come with fraction powers? Because remember, if the problem comes with fraction powers, we're supposed to give the answers. Fraction powers. Excellent. Score. We've got it. Number 4. Look inside those parentheses on number 4. Is that simplified inside those parentheses? There's something there that's not supposed to be. What is it? Yeah. So let's move that down to the bottom and get that taken care of right away. Remember, only the one that has the negative exponent has to move. That's a 27 to the 1st, which is a positive one. Oh gosh, now there's another negative. What do I do about that one? Flip it. Reciprocals. Now, we have 2 ways that we could take care of this. We could just distribute the 1/3. But so far, we've been thinking of it as cube root. Which one do you like? Which one do you want? Do you want to stick with what we were doing and do cube root? Or do you want to... Okay, so let's switch it to cube root, because that's the 1/3 power. Bless you. So on the top, what is the cubed root of x to the 3rd? On the bottom, what is the cubed root of 27? And then if you wanted to, you could break these 2 up. You guys did fantastic with that on the first test. So yes, I definitely would say if you're not getting the, hey, I'll just take 6 and divide it by 3 thing, write it out. You'll see y and y. And there it is, x over 3y squared. So don't be afraid to put extra steps in there. Make sure you're showing all your work so that I can see what was your thinking, what were you doing when you went through these. Alrighty, number 5. Cubed root of 6 over the 4th root of 6. Can we do this with roots? It's not the same root. We can't do it that way. So what do we do? Exactly. Now, Brianna, I wanted to point out, think about everything we've been doing so far. Fraction powers, right? And you get to this one and you go, oh my gosh, I'm stuck. Well, look at the test you just did. It's got to be fraction powers. So 6 to the 1/3 over 6 to the 1/4. Thank you. Now we can do that problem. In fact, this is the reason that we had to learn about fraction powers right here. So, when you have the same base on the top and the bottom and you're supposed to divide, what do? Ooh, that's a problem. So let's see. Common denominator for 3 and 4? 12 would be the least common denominator. This one will need a 4 on the top and the bottom. And this one will need a 3. I'm not even going to put that dot there. That'll probably just confuse the folks that are gone. So on the top, we would have 6 to the 4/12. And on the bottom, 6 to the 3/12. Now, what did you say we're supposed to do with those again? Subtract. Oh, that's pretty easy. 4 minus 3 is 1. 6 to the 1/12. Are we done? Did the problem come with fraction powers? So we need to put it back the way it came. So, wow, 1/12, what is that as an index for a root? 12th root. I don't think we've seen one that big yet, but that's the answer. Not that 6 to the 1/12 is wrong, it's just not best answer. So you're talking about maybe a quarter or a half a point on that. You did the math right. Alrighty, take a peek at number 6. Is that simplified inside those parentheses? It's not. When you have the same base on the top and the bottom, what are you supposed to do with those exponents? Subtract, yeah. Well, that works out pretty good because 2 minus a negative 8 will be 2 plus 8. Now this one, I think you'd actually make 2 steps out of this if you wanted to do it with radicals, and you certainly could. You could change it to 5th root of x to the 10th squared. But if you just figure out what 10 times 2/5 is, you've got this thing done. So remember, 10 is like 10 over 1, and when we do top times top, bottom times bottom, we would have 20/5, which is, of course, 4. Now, like I said, that doesn't mean you couldn't do this one with radicals. You absolutely could. Do the 5th root of x to the 10th, then square it, and you'll get the same answer. But that one goes a little bit faster since it is just fraction power of 1 little variable. So scared of the first page yet? Nothing scary, right? Okay, fantastic. Solve each equation, and I want to make sure everybody circles this, stars it, does something. Because you know we're probably going to have at least one on the test where you get 2 answers and at least one of them doesn't work. That's going to happen. And it's that we wouldn't have put the instructions there if everything was working out fabulous. So take a look at number 7. What do you think we should do? Yeah, square both sides because this is isolated. Remember, step 1 is always isolate the radical. So it is isolated. That'll give us x plus 2, and this will give us a really unfortunate x minus 18 times x minus 18. Ew. So then we'd have to FOIL that little bugger. First times first, x squared. Outside times outside, minus 18x. Inside times inside, minus 18x for a grand total of minus 36x. And then, oh, some of you had memorized 18 times 18. 324, yeah. When we were talking about our powers, some people had memorized all the way up to 20 times 20. Oh, that looks weird. So now what? Yeah, move everything over to one side. It's a quadratic. We're probably going to have to factor to solve. We need a 0 on one side because when you solve, you're finding the zeros. And this is why I wasn't too happy about the 324. Ugh. All right, so we're looking for 2 numbers that multiply to 322 and somehow manage to add to a negative 37. That would mean they both have to be negative. There's lots of you. Grab a calculator, start dividing. Let's find two things that will do that, because there is absolutely nothing special about this quadratic. If you find it, holler out so the rest of us will see. You already have it? Whoa, fantastic! 14 and 23. Must have been working ahead a little bit, trading, huh? No? Just accidentally found them. Cool. So our two answers would be? Maybe, right? Maybe. So let's check. And you always want to show a little bit of work for your check. So square root of 14 plus 2, does that equal 14 minus 18? Going way back up here to the beginning. 14 plus 2 is 16. What's the square root of 16? What's 14 minus 18? Uh-oh. One slash. Don't scribble. Give me one slash through it so I'll know that you know, hey, this isn't going to work. So let's check the other one. Square root of 23 plus 2, does that equal 23 minus 18? What's 23 plus 2? 25. What's the square root of 25? What's 23 minus 18? Oh, that one's good. So then, like I said before, check mark, circle something so that I know, hey, you went back and realized, yes, this one's good. This one works. Then, we already talked about this, at the end of the test, you've got it all done, there's 10 minutes left in class, you could always punch the left side in as y sub 1 on your calculator, the right side in as y sub 2 on your calculator, and make sure they only hit each other at x equals 23. That's one of those things you do after the test if you've got lots of time. Alrighty, let's look at 8. Interesting. Well, that 1/2 power is isolated on one side. How do we get rid of that? Okay, so you want to write it as square root or you want to square right away? I hear two things. Some people want to see it as square root. We can do that. So 1/2 power is square root. Now it looks just like the last one we did, right? So what would you do? Square both sides. What's negative 5 times negative 5? Yeah, be careful when you put that. If you're going to do that in your calculator, use parentheses, because otherwise the calculator will tell you it's negative 25. Well, look at that. We're not even going to have to factor solve this one. But then we remember, we circled or starred or boxed in, check for extraneous solutions. So 2 times 12 plus 1 to the 1/2 equals negative 5. What's 2 times 12? 24. 24 plus 1? 25. What's 25 to the 1/2? 5. Uh-oh. That's not true. Well, that was the only answer we got. What does that mean? There's no solutions. We didn't do the math wrong. There's no solutions. But if that happens on the test, I am definitely grabbing my graphing calculator and making sure those buggers never hit each other, because that would seem really strange. So, parentheses, 2x plus 1, parentheses, to the, parentheses, 1/2 power, negative 5, zoom 6. Oh yeah, they're never going to touch. There's no way that's ever going to happen. No solutions. Now, if we stopped right here Some of you maybe said to yourself, wait a second, if this is square root, that can't ever come out to a -5. And you maybe could have put down no solutions right away. But you'll find it either way. Just do the math if you need to and check your solutions. Alrighty, number 9. What are you thinking? No solutions? But this is cube root, so it could be. We ready to do something? Do we need to move something over to one side? Anything like that? Yeah, cube it. To get rid of cube root, we're going to cube. So -2 times -2 times -2. We don't have to factor this one either. But, of course, we would say at this point especially, I wonder, does it really work? Because we've had some issues so far. Two times -2. -4. What's -4 minus 4? Is the cubed root of -8 -2? It is, because -2 times -2 times -2 is -8. That works. So, again, at the end of the test, if you have time, y sub 1, y sub 2, make sure that it hits at x equals -2. Take a peek at 10. Seems like there's too much gunk on one side this time. What should we do? Divide by 2. We have to isolate that fraction power. Now, we're not going to change this one to a radical, and there's a reason. You'll see it in just a minute. What can we do to get rid of that 2/3? Raise it to the reciprocal power, so 3/2. And now here's the big step that people are going to forget, because we covered this in one day, and you guys had it down, and then we went and learned other stuff. Which one of those is the root? So we need the square root, and notice how I have to draw that, of 25, and then we need to cube it. What is the square root of 25? And yes, whenever we write down that square root symbol, we have to remember that it's possible. It could be a positive and it could be a negative. So we need to know what's going to happen with a -5. We might as well figure that part out right now. You maybe memorized this one. We used it so much. -5 times -5 times -5. Yeah, so let me write that step before we move on here. So x minus 2 equals -125, and x minus 2 equals +125. Well, we don't have to factor. That's nice. Just going to go ahead and add 2 all over the place. But of course, we would have to check it. So back in the original, it was 2. And then we had x minus 2, so -123 minus 2. All of that to the, I need my glasses, 2/3 power is supposed to equal 50. Now that one, you might just want to punch into a calculator to make sure it works. 2 parentheses -123 minus 2 parentheses to the parentheses 2 divided by 3 power. Oh, I forgot to write the 0 down for 50. There we go. And it works. Same type of thing over here. Again, you might just want to grab your calculator. You could do this one in your head too, because you could say 127 minus 2 is 125, cubed root of 125 is 5, 5 squared is 25, 2 times 25 is 50. But it's going to go a little bit faster if you just punch her in and make sure it's go. And it's a go. And there it is. But at least show the one step so I'll know, hey, you checked that and it's all good. Was this yours to fly away? Okay. Alrighty. Let's look at 11 and 12. Let f of x equal x squared minus 3 and g of x equal x plus 4. Perform each function operation and then find the domain. Oh, no. They don't get to tell us what direction we do this in. We know from doing these, that's where we want to start, is by talking about that domain. So let's go up here to f. Since this is a review, I need you to remind me what are the two things we look for restrictions on the domain. Even roots. See any even roots in f of x? What's the other thing? Division. See any division in f of x? All reals. G. I better put a little d of g, I suppose, so that people that are gone and d of f will know what we're doing. Do you see either of the things that we restrict domains for in G? All reals. So now all we have to watch out for is, as we do our math, is there any even root that we have to take, or is there any division? And I look at 11 and go, oh, look at that. There's division in this one. F of x is x squared minus 3. G of x is x plus 4. If I wrote a denominator, I need to tell them there's a number that's out. What number's bad down there? -4. And then I need to think, can I simplify that? Well, I could only simplify it if x squared minus 3 is factorable. Well, it's not a greatest common monomial factor that we can pull out. There's no perfect square up there. Do we know two numbers that multiply to -3 and add to 0? We're done. And that happened in the homework sometimes too. You wrote it down and you had to walk away. That's finished. I can't do anything else with that. Okay. Well, we got our domain restriction. That's why we looked at that one. We need to see that. 12. Every year, I hope that everyone will remember about what I said about the most common mistake made in mathematics, and nobody will mess this one up. And every year, about 25% of the class messes this one up. Tell your chicken wing elbow partner how they make their mistake. And if you didn't remember, do you remember now? What don't they do that messes up their answer? Every time. And I don't know why, because when we do this in class, everybody's like, no, we got to distribute the negative. Yeah, we're going to do that. And then you get to the test and somebody forgets. So there is a little math we can simplify there, right? What can go together? X squared minus x, this is an x squared and this is an x, so those are separate, but -3 minus 4, you know what that is, right? There it is. While we did that math, did we have to take any even roots? Any division show up? Fantastic. Then that's all reals, because that is the intersection of those two that we have up there. That was as far as I wanted to get today. Because even though we have 2 pages left tomorrow, it's less material, so we'll be able to go through that one a little faster. And I have a review assignment for you. It's on a little slip of paper. I'm going to bring those around. But it's the only review assignment that you're going to get. Did everybody hear that? You're not going to get a new one tomorrow. So it's basically for today and tomorrow. I'm going to get you this review slip. Because what I don't want you to do is to work on problems that we haven't covered yet, that you're not like, I'm 100% solid, I know exactly what I'm doing.